Good morning, everybody. Hi, it's Mo here from Inventables. We are here today to talk about gears. Now, if you were anything like I was when we first talked about wanting to do gears a couple weeks ago, I was a little intimidated because I don't really have a good understanding of gears or how they are, or how they work and exactly how to make two gears fit together to make something move. But as I've mentioned many times, we have an incredible team here at Inventables, and in the few weeks that we've been working on some gear projects, the variety and creativity of things that I've seen come out of this, the gear app that we have in Easel is absolutely astounding. So if you're brand new to gears, this is a good place to be. We're going to give you a very basic understanding of how gears work and also point you into some other resources if you feel like going down the rabbit hole that is understanding gears and mechanical movement. But I will show you how the app works in Easel, which will take care of a lot of the guesswork in terms of getting two gears to fit together. So with a little bit of background, as I said, many of us here that were working on putting together Easel Live didn't have a really good understanding of how gears worked together. And my colleague Sam sort of took on this project and really wanted to understand how gears worked with the gear app, and started off by just making this pegboard, just to kind of understand, like, how do these things come together? And this was the very first project to come out of Sam's experiment. It sort of works. It's this weird sort of like analog clapping robot that she had made. And it's the most bizarre looking thing that I've ever seen, but it also really kicked off this creative process for all of us here at Inventables to really understand, like, how do gears work, how can we make them work better in Easel, and how can we give you guys the tools that you need to make things that are like this, but might look a little bit more like Sam's second project that she made, which is a fully functioning camel that raises and lowers its head as it moves along a surface, right? Pretty cool. So Sam is a great example of someone who went from making something like this to something like this in a very short amount of time. And we're gonna help you guys bridge that gap. So before we start, I wanna give you guys a little bit of a background as to gears. So here's my little sample gear that we're going to use. And there's a few terms that it's good to know before we start using the Easel app, just so you have a good understanding of what the different functions in the gear app do. So first we're gonna start with some terms. The first term to know is a tooth. So the tooth is just these little spokes on the side of the gear. The tooth count will be how many of those gears are on the outside of the circumference of your circle. So the teeth and the teeth count are the most important things to know when you're looking at doing gears. The axle is going to be the center hole here that will be in the middle of your gear that you can use to mount different things. For the projects that we'll be using, we were able to use M3 hardware with a hole that is slightly bigger than an 1/8 inch. I'll show you that when we get into the app. But just so you know, this hole help you determine what kind of hardware to use so that you can mount your gears to, whether it be a suction cup, so you can put it on your tub or your window, or it could be mixing the gears together on a pegboard. That's important to know when you're looking at getting the gears to fit together. And the last measurement that we're going to need to know, which I will try my best to not make it too confusing, is called inches per tooth. And essentially what that equates to is the distance between the tooth and the distance of the tooth and the gap next to the tooth. So that total distance is going to be the inches per tooth. So essentially how many inches is in a tooth and that tooth's gap. Now what's important to know is when you're looking at a gear, there's two things that we can really see. The outside is the outer rim of the gear, and then the other line that's like really clear for us to see is the part where the spokes kind of come to the circle itself, which is known as the base radius. But the part that we really need to know in order to make gears work is called the pitch radius, which is actually between the end of the gear and the middle base part of the gear. I'm going to show you a quick diagram, which I hope is not going to be super confusing, but it is good to know if you are trying to like wrap your head around how this works. So let me show you this quick diagram that my friend Paul had shared with us. And what this diagram shows you is this pitch radius. So essentially it shows you how you need the spokes to fit together by understanding this line that falls between the base radius and the outer radius. So this red line here is really what makes gears function together. And you can see here that this line between them is going to be the distance between the two axles, so that we know that the two gears will come together and we can determine the distance that they need to be apart from each other. All right, so hopefully you're also with me after that. Didn't mean to be too confusing, but I, for one, really needed a visual diagram. If you want to take a look at that later, we can post that somewhere for everyone to take a look at. So it's important to understand why the gear app works the way it does, because when you first look at it, maybe some of the terminology is a little bit confusing, but I think that that will be a good starting point. Another good starting point, I suggest doing something that we did, which was to essentially make a pegboard that showcases how different gears work. So this pegboard here I have made, I've put some numbers on it, and the numbers correlate to how many teeth are on each gear. So this gear, for instance, has 30 teeth. This gear has 20 teeth, 10, 30, 20. And you can see the relationship between the gears and how the gears affect one another. So for instance, a large gear is going to make a smaller gear move faster. So you can see as I turn this, that the smaller gear is moving faster than it would if I was using the same size gear to turn the small gear. So a 30-tooth gear will make a 20-tooth gear turn faster than if I had a 20-tooth gear turning a 20-tooth gear. By the same token, a smaller gear, so for instance, this 10 gear is being used to power this 20-tooth gear, and using a small gear to move a large gear is actually going to make the large gear move slower. So you can see how if I were using a 20-tooth gear and a 20-tooth gear, they would turn at the same rate, but by using a 10-tooth gear to turn the 20-tooth gear, the 20-tooth gear is turning slower. So it's just kind of interesting to play around with these different gears and get an understanding of how they work and what kind of ratios to play into. So for instance, this gear, the 20 gear and the 10 gear, because the 20-tooth gear has twice as many teeth as a 10-tooth gear, it will turn the 10 wheel twice as fast than if a 10-tooth gear was being used to turn the 10-tooth gear wheel. So again, a little bit confusing to wrap your head around, but that's why I'd recommend downloading our template. I'll show you the template here really quickly. It's a great way to get started using gears. And it's really easy because you can just go ahead and download this Easel project. It's in our, if you go to projects, you can click into the Easel classes and you can see this project here, which includes some different pictures of the different things that we have made with the gear app since we started playing around with this. And if you click open in Easel, this will open up the pegboard template that you can use. And it even comes with a few different gears that you can use to just kind of get started and carving this out. It's a quick carve and it'll help you kind of wrap your head around how to use gears in a very simple way. Think of it as a way of just playing with gears to get a better understanding of how they work. All right, so let's move into our very first project. We talked about doing robot hands, and yes, this is totally robot hand 2.0. A pretty complex design, but once you understand the basic mechanics of how this works, it's actually very simple. So we're gonna step back from this kind of a design really quick, and we're gonna go to a design that I made because I like to keep things simple when I'm learning. And I figured what better way to do that than using my favorite emoji, the flexing muscle emoji, and making this really bizarre looking muscle flexing machine. So we're gonna make this project really quickly just to get a sense of how to get two gears to work together in conjunction like this. So without further ado, give me 1 second here. We're gonna go into Easel and we're gonna get started on making this project. So here we are in Easel. Again, I'm gonna be using a Carvey template, which explains what this is. If you have a Carvey, you're familiar with the Smart Clamp Guide. If you have an X-Carve, don't worry about this, but this is just so we can show people how to use, how to build these designs specifically for Carvey, since that's our smallest wasteboard work area that we provide to people. So first things first, I'm gonna keep my bit at an 1/8 inch, and I'm going to change my material size to a 1/4 inch. since that's what I use to make my biceps. And I'm just gonna go right into it. If you go into the apps, you can see we have changed our app library to make it a little more user-friendly. We've included some fun little GIFs to help people get a better understanding of as to how some of these apps work. And you can see some of our old Easel projects here. But the one we're going to use here is the gear generator. This was made by my good friend Paul, and he's made some changes to it recently. So if you tried using the gear generator previously, you might find that it's a little bit more user-friendly now. So let's go ahead and get started using this new template. Thank you to Paul for helping me understand gears and also for putting this awesome app together, making some really great changes for us. So to make my bicep, I used 2 gears that are exactly the same size. So they have the same number of teeth. In this case, I used 20 teeth on each of my gears. And the inches per tooth can stay the same. Now, one thing that's really important to know is that regardless of what this inches per tooth value is, this value needs to be the same for any gears that you want to put together. So let's say I wanted to make this gear 60 teeth. As long as this inches per tooth is the same for both of these gears will work together. Now, the other cool thing that the gear generator app will do is give you the holes so that you can mount these gears at the proper distance. So you can see when I import my gears, I'm not only going to get the gears themselves with the proper axle, but also the holes that correspond to the axle so that I know exactly how far apart these gears need to be if I'm going to mount these gears onto something. So let's back up. I'm gonna make these both 20 teeth again, and I'm gonna keep my inches per tooth the same. And for my axle, I'm going to use 0.128. Now I know that I had said previously that we used hardware. We used M3 hardware to mount all of our pieces together. And so 1/8, the M3 hardware normally corresponds to about an 1/8 inch, but I have to go a little bit bigger just so that Easel will make sure to carve these holes out properly. So I'm going with my axle is 0.128 so I can mount my screws in here when I get my biceps all generated. I'm gonna go ahead and import these shapes. So you can see here, these are the holes that I'm going to use later. I'm just gonna set those aside for now. And I've got my 2 gears here that are going to correspond. You can see how, you know, in the end, they're gonna fit together. And so I've got my gears, and now I'm just gonna go ahead and use image trace to import my biceps. So we've shown this a few different times. Go ahead and go to image trace, upload file, and to save some time, I just went ahead and I found a file on the internet that I will import for us. I like to set my smoothing all the way up just so there's no rough edges or corners that my bit has to try to navigate around. And then I'm gonna go ahead and import that. You can see there was a little strange piece from the image that I'm just gonna delete because I don't need that to complete this project. And now I got my 2 arms, which I'm feeling pretty good about. All right, I'm just gonna choose both of those and expand them. And I'm going to just kind of place them over where I'd like them to be on my gears. Just try to keep things sort of symmetrical here, line them up. If I'm feeling fancy, I can select both my items by doing select and click. And I can go ahead and just make sure that they're aligned properly so that they're even on the 2 gears. And you might be looking over here at my simulation and you might be thinking, well, that's not really at all what you had made. We've talked about this previously where sometimes when you're designing an easel, it's easier to keep things all set as a fill while you're playing around and trying to figure out what your design is going to look like. And then later on, when you're ready to finalize your design, you can go ahead and convert it to an outline. And that'll make it easier to carve. But this way, it's simpler to design by just looking at these 2 pieces. So I'm gonna go ahead and select these 2 items. And what I'm gonna wanna do is combine them so that I have one unit that will carve out together. So I'm gonna go ahead and just right click here and hit combine. And now I've combined, I've got my 1 piece, my 1 bicep here. I'll come over here and I will do the same thing with this one. Right click, combine. And now I've got both my shapes. I'm gonna go ahead and set them to outlines. Now, the other important thing to keep in mind when you are using gears and you're using the gear app is you want all your cuts to be set to outside. This way you are keeping the actual tooth size correct. So by having my path on the outside, you can see that the full tooth size is going to remain intact. If I were to carve this on the inside, you can see I completely lose the shape of the gear because that's being carved out by the bit. And if I have it on path, it'll still work, but see how small my teeth are? I'm not gonna get a really great fit the way I have with my current model. So it's important to make sure when using gears, you set your cuts to the outside. The other thing I'm gonna do, because I'm a kind of a foolish carver, I'm gonna go ahead and remove my tabs because I'll use double stick tape to keep these. Tabs are a little bit tricky to do with gears because you're gonna have to, sand them off or somehow remove them. With something like this, I could use tabs on this part of my project that isn't as much affected by the mechanism of the gear. But for simplicity's sake, I think I'm just gonna go ahead and stick with having no tabs for this project. All right, so there you go. That's a very simple way to make a quick mechanism that these two gears, when I carve them out, they will fit together. And you can see here from the holes that I have between them that these two gears will fit together quite snugly. And now I've got this last part of my holes. So you can see here, because of the way that I have to carve these shapes, it might look like these two shapes are not gonna fit together, but these two holes are spaced correctly so that when you carve out the arms, they will mesh together perfectly at that pitch radius and cause the mechanism to move. So what I'm going to do with these two holes now is I'm going to create just a word that I made up to describe what I was mounting my pieces on. And I'm going to go ahead, I'll just set this to outside. Again, reckless carving without tabs. And I'm going to go ahead, use my line tool to make sure those holes are mounted in the center of my backboard. And now I've got a piece on which I can mount my two arms. And that is honestly all there is to it. So this is, like I said, the robot arm I first showed you is a very complex mechanism that is essentially based on the way that these components work. So you can see that all that was done from this model to this model was adding a few more arms so that these pieces all join together, right? But essentially, this is the exact same movement and it operates in the same way. It's a little stiff because the engineer who made this is a genius and has like very intricate formulas, and I don't know how his mind works. He's just amazing. So this is a really tight fitting gear that is really an example of how far you can go with using the simple things that I just showed you in my little bicep preview. So there's one last project I want to show you because when we were first talking about gears, my colleague in customer success, his name is John, he instantly said, he's like, well, you guys should make a spirograph for Easel Live. Like, that would be awesome. I was like, oh my gosh, you are right, because I love spirographs. I have a secret spot in my heart for the simplicity of the spirograph, which now I know is not so simple. It's actually very complex, but Easel just happens to make it very simple to make. So my other friend, John, he created this wooden spirograph that I absolutely love this thing. I'm always up here playing with it. And I'm gonna just show you really quickly how you can make a spirograph. Essentially what we're going to do is we're gonna use two gears, but you can see how what we've got here is the gear and then a reversed out gear. So some of you who are familiar with masking and different techniques we've used in other Easel Live videos might find what we're about to do a little bit familiar, but if you need a spirograph in your life, as I'm sure we all do, then this is a really great way to just make this up really quickly. Great for kids, and it's a really simple, fun project. So let's get back into Easel, and I'll show you how you can make that. So I'll go into Easel here, and first I'm just gonna save this one as biceps, because why not? Gotta remember that project. All right, I'm gonna head over here. And you can see, if you've not been in Easel in a while, we have some new organizational features so that you can quickly access your projects and get little preview thumbnails. Keep in mind that you do need to open up a project for the thumbnail to appear. So open up a project, make a small change, maybe just add something and then delete it, and then the screenshot will appear here for you. So if you're having trouble getting the screenshots to show up, try saying that 3 times fast, Just go ahead and open up the project, make a small change, and the project will automatically resave. Now, without further ado, I'm going to make a new project. And since Spirograph is copyrighted, we'll just go ahead and call this Spiral Drawing Toy. All right, so we're in here now. The Spirograph has a few different things that I just want to go ahead and make really quickly. So we did use a 16th inch bit for the Spirograph. Most of our projects we can do with an 1/8 inch, but with the way that the Spirograph pieces need to fit together, I would suggest sticking with the 16th inch bit so you can get those really fine details. And the other thing we did is on this particular Spirograph, the material was actually a 1/8 inch thick. So we're going to go ahead and just change the thickness of that as well. We did find that the smaller, the thinner pieces of wood actually made for better Spirographs. We got a better fit of the gears together on that. So without further ado, we're going to go back into our apps and go into the gear generator. And here we're going to make two apps that are different sizes with different number of teeth. However, they're going to have the same inches per tooth. As I said previously, as long as these inches per tooth is the same, you will be able to have gears of different teeth amounts fit together. So the first gear I'm going to make is going to be the outside of the Spirograph. So this one, I'm just going to go crazy. We're going to make it 100 teeth, because why not? And the second gear that I'm going to make here is going to be slightly smaller since it's going to fit inside this. This is where Spirograph is a lot of fun because you can come up with any number of different size tooths to use for the center part of the Spirograph. But in this case, to make it easy, I'm just going to stick with 75 because I know that that will fit inside this 100 tooth gear. And I'm going to make my inches per tooth a little bit smaller just so that I can get that more fine detailed movement between the two pieces. And the axle in this case doesn't really matter because I'm not going to use that part for this thing. You'll see I'll get this pop-up that says that the imported design is larger than my work area, but I'm just going to go ahead and leave it at the original size because I know what I'm going to need to do here. So I'm going to go ahead and delete the holes since those won't be necessary in this project. And for starters, I'm just going to go ahead and work with this gear. This gear is going to be the center part that I will use, or sorry, the outline that the gear will move inside of. So I'm going to go ahead and add in a square, and I'm going to make this square 7.5 by 7.5 inches. And that will make sure that it can fit onto this piece of material inside my carving. And then I'm going to right click again, and I'm going to send this piece to the back. Now, I mentioned this already, but like I said, if some of you are familiar with our masking techniques that we've used previously, what we're essentially going to do here is the same thing. So we are going to set the gear to a depth of 0. And you can see I've got this axle in here. I'm just going to mask that as well because I don't want that in my shape. And now when I do, I'm going to combine these two pieces. Oops. Now I'm going to mask that. All right. So now I've got my piece here, but again, this is not exactly what I want because I actually want this, I don't want to carve this part out. I want to have a solid piece that is removed. So again, I'm going to set everything to an outline on the outside. And you can see now in this preview over here that what I'm going to get when this cuts out is I'm going to get a mechanism that will carve out these edges so that this gear over here is going to fit inside of the grooves that are created. So that is how I make the template that I need. And now, if you want to save some space in your carving, go ahead, just take this shape and make it an outline. Again, outside cut, and we won't use tabs. But let's make everything a through cut first. All right. So this shape over here, I'll move it over here for right now to make it easier to understand what's going on. What I'm going to do is I'm just going to start playing around with different shapes to put inside of the gear. So again, I'll just show you this really fast. But the fun thing about Spirograph is that you can come up with any kind of shape to put inside of a spirograph, and it'll make the coolest designs that you didn't even think was possible. Obviously, you can start off very simple, just use little dots. For these, again, make sure you can get your pencil all the way through, so you might want to make them big enough to make sure you can get a pencil or a marker or a pen, whatever you need to get into there. But we have a lot of fun with like this shape. This shape makes really cool spirographs. I would stay away from squares. Squares do not make the best spirograph shapes we found. It's a little depressing. You'd like it to work, but it just really doesn't do anything cool. But you know, a lot of these other designs that we have, just kind of play around, see what works for you. So, and again, like I mentioned, so this is just one size that you could make for your spirograph. But you could make a smaller one. You could put 2 gears together and have those move around as one unit. You can do, you know, all kinds of different shapes can be used in a spirograph, and any number of teeth, as long as the inches per tooth matches the outside of your spirograph, you'll be able to use them in the spirograph. So let's go back really quickly into Easel, and I'm just going to show you what I did. Is I used the pen tool to just kind of draw some fun little shapes, and I just clicked on edit points here. And what I found is that rounded shapes really work best when using a spirograph. It just makes it easier for your pen or your pencil, whatever you're using, to not get trapped in a weird corner. This is probably not a good shape to have. And then just set all these to through cuts as well. And don't use tabs on those because we don't really need them. What we're more interested in getting is the shape here on the outside. So when these cut out, when this gear cuts out, I'll be able to have these different shapes cut out. And you can even just, you know, stick with adding in some circles if you wanted to do that. You know, there's really no right or wrong way to have a spirograph. It's kind of cool to just play around and see what kind of shapes you might come up with and how those impact the design. It's a great way if you've got kids to sort of teach them, you know, how like you could, you know, ask them how something might work if you had a shape like this, like what kind of a spirograph design might that make? So spirograph, in case you're wondering, is obviously something I'm a huge fan of. If you can't tell, I would make spirographs all day if I could, but I guess I have to do other work sometimes. So then when I carve this out, you can see here, I'm gonna, let's go ahead, I'm gonna move these guys aside. So when I carve this out, because of the way the shape is gonna carve, right? This is gonna be an open hole, and then this is going to be the solid piece that will be carved out. It's possible, if I wanted to actually just carve this right inside of this. And the nice thing about that is it means if I wanted to, I could add in another gear. Again, keep the inches per tooth the same. And I could just go ahead and import those and make a couple other fun spirograph designs and carve those out in the same area so I can get the most out of my material. So that is the simplicity of gears. I'm hoping that that really explained a lot of how gears work. There is something else I just want to show you guys really quickly. If you are really trying to get your head wrapped around gears, I encourage you to carve out that template that I showed you with the pegboard. It's a great way to start, just kind of figuring out, you know, how gears work and how to get them to move together. But there's also this really great website that my colleague Paul shared with us that at first glance, I was pretty intimidated, but it's this gear generator site that allows you to see, you know, you can change the different teeth on these gears and see how that impacts the movement of the gear. And then what's actually really cool about this is you can then download the gear as an SVG that you can then import into Easel and carve. So it's a pretty cool thing to check out if you really want to make a bunch of gears that fit together. If nothing else, this is the most mesmerizing mesmerizing website to look at and just kind of play around with it. It's sort of soothing in a way. So check out this geargenerator.com, pretty simple URL, and you can play around with gears, export the SVGs, and use those in Easel if you're looking to take your gear game up a notch. That's all we have time for today. I appreciate everyone tuning in, and if you're new to gears, I'm really glad that you stopped by. Hopefully you learned a thing or two. I know I have learned a lot in the past few weeks about gears. If you have any other questions, feel free. You can go ahead and we'll be on chat for a few more minutes answering any questions that you have. If you have some follow-up questions or need help with anything else, You can always reach us at help@inventables.com. I might take your email or your phone call if you get in touch with us that way. So again, my name is Mo. Thank you again for tuning in, and we hope to see you next time. Thanks.